Hi, and welcome to our webinar. My name is George Land, the VP of Customer Care with Nextivity, and I want to thank you for joining us this afternoon. We're going to talk about what happens when you get multiple input signals at different signal levels from multiple carriers. Now, if you've got a traditional DAS system, this can be a challenge, but with a little help from my buddy Steve Van Skyke, one of our solutions architects, we're going to tell you how Cel-Fi deals with that situation. Now, Steve, what I think I'm going to do is just hand it over to you. I'll hang out here in the background, and if anybody's got questions, they can just pop them into the question module, and I'll either type out responses to them, or if it's a good question for the whole group, or something I don't know the answer to, which is more likely, then Steve, what I'll do is I'll interrupt you and ask you to answer the question. So, take it away, Steve.
Okay. Let me get everything set here. All right, my name is Steve Van Skyke, and I'm going to be talking about unequal coverage from bidirectional amplifier systems today. It's a very common problem, and it's with the broadband amplifiers, it's very, very difficult to resolve, but something that is inherently taken care of in the Cel-Fi QUATRA system, and that's what we'll be talking about today. Let me page 2. Excuse me, something has happened and I apologize. All right. The first thing I would like to do is just do a very, very quick refresher of the QUATRA system. So for those of you that haven't seen it before, it's very different than a traditional DAS. It's a digital system, first of all, instead of an analog system, and that gives us a great deal more processing power. It allows us to do a lot of different things with the channels that are coming from the operator that cannot be done with a traditional DAS system. First of all, our coverage units, they're connected to the network unit and they deploy over Ethernet cable, just like Wi-Fi access points. Sprinkled throughout the building. Ethernet cable is very inexpensive, of course, and because it's a digital system, we can go a great distance with these. It is lossless again, which means that the signal that's being delivered to the coverage unit being digitized, it's actually amplified within the coverage unit. That's where the amplifiers exist. So we don't end up with the losses that are inherent with a distribution system of coax, taps, and splitters. Full power is delivered up to 650 feet away from the network units. We also enjoy 100 dB of gain, and that becomes something that's really important because traditional systems, you really have to worry about gain because their gains are limited, which means you have to worry about the level of the donor signal that's coming in. But with 100 dB of signal gain, you really don't have to worry about the level of your donor signal, and you can concentrate on something that's more important, which is actually signal quality, because that's what you want to deliver to the users inside the building that you're trying to cover. You're trying to give them a good experience. The architecture is also powered from a single power supply that powers up to 4 coverage units and 4 range extenders. Those range extenders let your cable go from 100 meter to 200 meters in maximum length. That's the 650 feet. And that way you aren't sourcing power for any of the equipment that's out in the field away from the network unit. And a single system will cover about 50,000 square feet. Obviously, it depends on the type of the layout of the structure that you're covering, but coverage is substantial. Output power is very, very good. You can get more than this, you can get less than this. And for buildings that are larger, you simply use more systems. Now let's get into the problem of unequal coverage. What is it, first of all? You can imagine that if you're standing on top of a building with a bunch of your friends and everybody has a handset from a different carrier, in this case carrier A, B, C, and D, and everybody's going to get a different service quality, number of bars on their phones, etc., from their phones, and that's because the carrier networks are independent from each other. Your tower may be, for your operator, A in this case, is much closer to you, so that person holding a phone for carrier A is going to get a great experience, whereas the other operators, their towers might be further away. And as you can see, carrier D here is only showing a couple of bars because carrier D's tower is much further away. Now, when you deploy a bidirectional amplifier, what you're really doing is taking that outside experience and replicating it indoors. Now, you're going to be able to adjust it to a point based on how you aim your donor antenna, but it still becomes a bit of a challenge because the gain of a bidirectional amplifier for a given band is something that's shared between all of the channels that are coming in within that band, which means that the dominant carrier channel that's coming into the donor antenna is actually going to consume, it'll be the marker for which you set your gain, and it's going to consume most of the power of your amplifier. Now, the problem with that is that the other operators that you may be more interested in, because those are the ones that are not penetrating the building well, those are the operators' channels that are weak inside the building, the problems that you're trying to solve, those are actually getting a lot less power because you're assigning the same gain to their donor signals that you were, in this case, to carrier A that was consuming all of your power. And this results in a lot less coverage for those operators that were coming in as a donor signal at a much weaker level. If you take a look at this chart, you can kind of see coverage bubbles, if you will, from a service antenna. And this is what really happens in the real world. You end up with less coverage for certain operators and more coverage for other operators. So what can we do about this? Is there anything that we can do in particular to try to resolve this problem? Well, unfortunately, with the bidirectional amplifier, it is a problem, and about the best you can do is to try to aim your donor antenna appropriately. Imagine you're on top of that building and carrier A is coming in very, very strong, which means it's getting into the building fine. Maybe their tower is right next door or very, very close, and it's really swamping you with energy, and the other operator cell towers are much, much further away. I actually need to take that donor antenna and try to reject the signal coming in from operator A because I don't need it and I don't want it dominating my channel power. I'm much more interested in the power coming in for operators B, C, and D. So you can understand the challenge with this. And what happens in the future after you have deployed a system at a site? Things change, right? The operators can refarm their frequencies. They can change power levels to their towers. They can use different antennas. All sorts of things can happen. And that makes it not future-proof. I mean, because you just don't exactly know what scenario is going to be at this site tomorrow, a year from now, 2 years from now. Now, the Quatra architecture, being a digital system, again, is something that's very, very different. The fundamental difference that we're going to focus on here today is that Quatra channelizes the signals that are coming in from each operator. In other words, it processes each one completely separately. Therefore, in this case, operator A that's coming in, carrier A that's coming in really strong, will simply apply less gain to it through the system, whereas the channels that are coming in from carrier B, C, and D at their respective lower levels, they don't get robbed by the power consumption that's occurring from carrier A. They each get gained independently. And enough gain will be applied, assuming that you have good isolation between your coverage units, of course, and your donor antenna. Then the goal here is to provide maximum transmit power from the coverage units for all individual channels that the system is relaying. And by the way, and all this happens in real time. In other words, it isn't something where you have to go back and touch the system in the future if the operator changes things. Cel-Fi systems operate very much like phones do. They power control off the networks, and they decode the overhead information that cell phones are privy to. In other words, things like channel priority or channel quality metrics, things like that, the Cel-Fi system understands, and it gets to make use of all of that information when it decides what channels to relay or how to amplify those channels. And it happens very, very quickly, again, and in real time. So if the operator does any changes in the future, refarms their spectrum, puts up new towers, etc., the system will simply keep up in real time, and you should never have to go out and touch it for any reason. The result, of course, is, again, a higher power density output per channel. And our goal, again, is to normalize the channel power for each of the operators so you don't end up with these unequal coverage problems in your distribution network through the Quatra system.
Steve,
yep.
Quick question for you. You said that in a traditional DAS system, what you might want to do is actually point the antenna away from the strongest carrier so that you don't get overwhelmed or it doesn't become the one that sets the gain level for all the rest of them. Is there anything inside of a Cel-Fi system, Quatra, any of the rest of them, that actually help you figure out where you should be pointing that antenna?
Yes, and that's a very, very good question. To first talk about it from the bidirectional amplifier perspective, it has no idea what channels exist in what portions of the frequency of a given band. It has no idea, which means you'd have to use extra equipment outside of the system to try to figure out if your power is being robbed by a specific carrier and if you're being shortchanged by somebody else. So it would be a very manual process with expensive test equipment in general to find out. You can do certain things with your phone, but it takes a lot of back and forth because it isn't something that those systems understand or can deal with natively. Quatra systems are connected to what's called the Wave Portal, and the Wave Portal gives you a wealth of information about the donor signals, about the gains and power levels. You can see everything happening in real time. Quatra 1000 systems enjoy an antenna aiming feature, which takes a look at signal level, signal quality, and isolation to help you determine the best direction to point your donor antenna for, again, the best experience indoors. Because remember, we care less about the signal level because we have lots of gain. We care more about signal quality that we decode, and that's why we incorporate that into antenna aiming.
Okay, one more question while we're here. Rick wants to know how much isolation in dB is between the adjacent channels. For example, if you set up a Quatra solution next to an AT&T base station emitting 740 megahertz, how much leakage is there onto the Verizon 751 meg?
So the phase noise, the skirts out of base stations are fairly good because they use good cavity filters. There is a maximum, I believe it's an FCC rule, but there's a maximum allowed of input energy where we could actually alarm off of. The survival input is over, I think it's over a watt for Quatra, but we're talking about swamping the front end with energy from a nearby tower. Of course, that could happen. The chances of you having a tower that close to the system is actually, I think I've only seen it once in my experience. Maybe others have seen it more, but it's true. You may, what it would show up for us would be a reduced signal to noise ratio. In other words, it would be handled by the antenna aiming algorithm.
Okay, thanks. Carry on.
All right. So it's basically the end of the conversation. This is the architecture of a digitized Quatra system and handling each one of the channels and power controlling each one independently so that we can apply the gain where we need to get maximum output power. There are two different types of Quatra systems. First off, we have the Quatra 1000. This is carrier specific, where all the radio channels are dedicated to a given carrier. These are what are deployed in most places around the world. Remember, Nextivity is an engineering company that provides network equipment to operators around the world. We've been qualified by about 200 operators in 100 countries around the world. But in the United States, we also have the Quatra 2000, which is a dual carrier system. If you wanted to deploy all four major operators in a building in the United States, you would put in two of these systems in parallel. And then there would be radio resources designated to each of the four operators and again normalized at the output. Another difference between the 1000 and the 2000, the 1000 is a MIMO system. So you get to enjoy the enhanced data rates of MIMO. And the 2000, which is the multiple operator system, is a CISO system. And these, by the way, can be mixed and matched at a site. You can have as many systems at a site as you want, and they're all a part of the portal together. Some buildings will use 1,000 systems where they have a high density of users and they really want the capacity of MIMO. And then in other areas, other floors within the building with fewer users, they may use 2,000. So it's okay to mix and match these. For more information, please do visit us. You can see our website URL at the bottom, www.cel-fi.com. Go to the product page for Quatra, and there are all sorts of downloadables. And of course, if you join us, and many of you have already done this, we have lots of online training tools and things like that to help you understand how the system works and how to deploy it.
Okay, great. So Steve, if you want to close your presentation, we'll just take a couple of minutes and answer some questions. There have been a few that came in that I asked you during the session. I also answered a couple from my desktop here because I'm in Command Central. But in general, I think the topic was pretty straightforward. There haven't been a whole lot of questions, but if anybody's got questions, please feel free to ask them now. I should let you know that there is a webinar coming up that we'll announce in the very near future about the use of combiners and splitters. I'll get a date and a sign-up link out for that. I also wanted to remind you that if you missed any of our previous webinars, you can see them all on demand on demand streaming from our website if you go to www.celfi.com and then /webinars. So Taylor said he enjoyed the seminar. I don't see a whole lot of other questions. Steve, unless you've got anything else, I think we'll wrap this one up. It was a pretty quick, straightforward topic.
No, I think that's great. Appreciate everybody being here today. And if you do have any questions, again, visit our website or give us a call.
All right. Thanks a lot. And thank you, Steve. Thank everybody for joining us.